Something a lot of people find useful when thinking about probability are these things called probability trees. So that's just a sort of diagram for thinking about probabilities, which I'm going to show you. And in these cases, I'm going to show you the order of events doesn't matter. That's just a little disclaimer. If the order does matter, then you probably want to think about it a bit differently. So first of all, let's think about a coin toss. So all I'm going to do is say heads or tails. And half of the time we're going to get heads, and half the time we're going to get tails. And then we can expand on this. So how about, what is the probability of tossing a coin twice and getting 2 heads? Getting the outcome heads twice. So here's the first flip. So you've got these 2 different possible events. So half the time we get heads, half the time we get tails. And then if we add a second flip, then the same thing happens. So here we've got half the time. So here we've already got heads for both, and then half the time in here we're going to get heads, and half the time we're going to get tails. Same here, we've already got tails, then half the time we get heads, half the time we get tails. And these are all equally likely, so we can just add them up. So there are 4 different ones, so a quarter of the time we get 2 heads, quarter of the time we get heads then tails, quarter of the time we'll get tails then heads, quarter of the time we'll get tails then tails. And this should add up to 1. So this is an exhaustive list of the different events that could happen. Okay, so we just draw these lines to sketch out the different outcomes that we could get. Now how about a genetical example? So what's the probability of an offspring of a single offspring from 2 heterozygous parents, so they're both big A, little a, is their genotype, also being heterozygous at that locus. Okay, so traditionally we would use a Punnett square. So we're looking at the mummy and the daddy, and they're both big A, little a. So we work this out. So the Punnett square tells us that half the time, 2 out of 4, or 1/2 of offspring are heterozygous. So that would be the chance for one individual as well. We can do the same thing in using this diagram. So first of all, let's look at the maternal. So it doesn't matter which order they come, I just happen to do it like this. So half the time we'll get a big A, half the time a little a. And just the same as before, half so the same thing from the father. So it could be so half of these are the dominant, half of the recessive. So again, we count these up. So this is a quarter, quarter. These are all equally likely, a quarter. And what we want is these two. So that's a quarter plus a quarter, or 1/2. So we've used this diagram instead of a Punnett square, which might be more convenient if we're doing something more complicated than just a single allele. And the really important thing that I didn't tell you here is that these are independent events. So the outcome of the first Toenkos won't affect the outcome of the second, and the outcome and which gamete comes from the mother will not affect in any way which gamete comes from the father, from the male parent. So that's really important to make clear.